Welcome to Year 1 Mechanics, Chapter 10.4, where we continue to look into forces and friction. In this lesson, we are going to use forces as a vector. And actually, we have actually touched upon this a little bit before, where we know the resultant force in a vector, when forces are in vector form, the resultant force is simply adding all the force vectors together, right? So we know forces are magnitude and direction, and we can represent them as vectors. So the big thing, the difference between vector, force is a vector rather than a magnitude, let's say 5 Newton, 6 Newton, is that when you're given direction, when you want to find a resultant force, add them together, okay, as a vector, column vector. Okay, so find the magnitude of the acceleration of a 3 kilogram block under three forces. So you've learned about F equals ma. Okay, rather than using x and y direction vector, combine them two together. So simply, if we use F equals ma, the resultant force will equal to, you simply add the forces, the vector forces together. 2i plus 4j. I like to write as a column vector because that's the easiest to read and the easiest to do the calculation, as long as you are not copying it incorrectly. Some students, forget sometime when there's 6 minus 5, got a minus 5, etc. So you'll make silly mistakes like that. But anyway, if you do correctly, you should get 3 and 3 in here. What does that mean? That means when we do F equals ma, this 3 becomes our force on the left hand side. And the mass is 3 times a. So when we divide by 3 across, you divide every top and bottom by 3, so it becomes 1 and 1. So therefore a equals 1 and 1. But they want to find a magnitude. Okay, so to find a magnitude, so that's the acceleration, 1i plus 1j. That means in terms of direction, that means we're going 1 and 1. That means that direction. So 1, 1, right, for acceleration. So how to find magnitude? Magnitude is simply the Pythagoras of the two numbers, 1 squared plus 1 squared, which is root 2. But we know mechanics, we don't like to write square root, so we're going to write as 1.41 meter per second squared. All right, simple as that. Example, a 60 kilogram bolt is accelerating at a rate of 0.8, 1.5 meter per second squared by three forces, where ATI plus 50J, F2 equals 10 PI plus 20 QJ, and F3 equals that one. Find the values of P and Q. So you've only learned one formula, F equals ma. So what's the force? The force is the sum of the vector forces. So 80, 50 plus 10P, 20Q plus minus 75, 100 equals the mass, 60 times acceleration, 0.8, 1.5. So F equals ma. On the left hand side, let's simplify this by adding all the terms on the top row. 80 minus 75 is 5. So 5 plus 10p. For the bottom, 50 plus 100 is 150 plus 20q, which equals to, if you sort of expand a bracket that way, 60 times 0.8 is 48. 60 times 1.5 is 90. So in here, what we can do is we can separate the numerator and denominator. And numerator and denominator is incorrect because it's not a fraction, right? So it's like calling Coke, cola as Pepsi, Pepsi as Coke. They're different. I prefer Coke over Pepsi. Right, so if you separate top row and bottom row, the top row give you 5 plus 10p equals 48, and the bottom row, 150 plus 20q equals 90. Then what we have is, if you simplify, if you solve the numerator, I keep saying numerator. Pepsi and Coke is not the same. This is not a numerator. Vector and fraction not the same. So anyway, so if you solve the top row, the first equation, you get P equals 4.3 and Q equals minus 3. Okay, and that's it. So practice question 1, the only practice question for you in this lesson. So pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the final answers. Got it right. End of lesson. But if you don't, let's have a look. So find the acceleration. So we know F equals ma. Question A, F equals ma. To find the F, we add up all the vectors together. 4 minus 2 plus 3, 1 plus minus 8, 4 equals 0.5 times a. So if you simplify the left-hand side, numerator, I keep saying numerator, left-hand side is minus 1, 3 equals 0.5 a. So, and then if you divide by 0.5 means doubling the left-hand side, you get minus 2, 6. The question wants us to put in I and J form, so we have to write minus 2i plus 6j meter per second squared. Okay. Part B, find the magnitude of bearing. So first of all, I know bearing, when we say bearing, a lot of students will have PTSD or nightmare with this word. I don't know, I don't get why. But anyway, magnitude, let's do it step by step. Magnitude means do the Pythagoras of the two. You can put a minus in here and put a bracket around it, but we know it doesn't matter. The minus doesn't matter because the minus, when you square negative, you get positive. So plus 6 squared, which you get 6.32 meter per second squared. Find a bearing. So what's bearing? Bearing is merely an angle from north. So right in here. Okay. So for last time I will explain. So bearing is simply an angle. Okay. Measure from north and clockwise. Okay. If you want to be really technical, it has to be 3-digit, not 30-digit, 3-digit. But that's bearing. Right. So what do you want to do? Well, first of all, let's draw out A on the axis. So we know acceleration has direction minus 2i plus 6j. So minus 2i means from here we go minus 2 plus 6j. Oh, plus 6j means that way. Okay, am I right? Minus 2i plus 6j. I think I made a mistake. The answer is 242 degree. Right. So anyway, so in here, 242 degree. So what we need to do is, so we can draw the vector of A, so that will be that way, right? So that's A. Okay, and what we need to find out is this little angle theta. So how do we work out theta? Well, using SOHCAHTOA or trigonometry, whichever way you would prefer calling it. So you get tan theta equals 6/2. So theta equals inverse tan of 6/2, which you should get as 71.6 degree. And clock bearing means we measure from north clockwise. So north line is here, clockwise here. So what's the answer? Well, we know that's 90, that's 90, that's 2, and then that's 90, so 270. So the bearing is going to be 180 plus 71.6 degree. 180, 270, sorry, I mean 270. 270 degree plus 71.6 degree, which is indeed 342 degree. So if you're here wondering why the answer was 198, it wasn't. I'm just tricking you to ask you to listen to the end of the video. No, the answer is 342. I messed up. Okay, 342. And that's the end of the lesson.